Good afternoon, everybody. It's a pleasure to be here. My name is Julian. You may remember me from my AWS days or my Hugging Face days. Still the same guy, just a little more tired, I guess. And now I'm working with Arcee, and I actually have colleagues here. Can you guys wave? All right. So if you have questions, don't ask me, because I'm jet lagged. Ask them. You'll get much better answers. But you can still come and say hi and ask simple questions. Okay? So, yes, I am going to talk about small language models. But before I do that, I need to set the scene a little bit. So, a couple of years ago, all we had was closed models. And they were cool, they were useful. They helped educate a ton of people on what AI really was, and particularly what AI could do for businesses and enterprise use cases. And the open source community started running. And fast forward a couple of years, where, we've come to the point where the quality of open source model is just undistinguishable from closed models, as you can see on this very nice graph. So the latest models from Meta and others are just on par with the largest and best closed models from OpenAI, Anthropic, the most important ones, right? So that's a given. I'm not even going to argue with this. There's no arguing. I think it's a fact. And because I like to look a little forward, it's very clear to me open source models are state of the art, and they're winning this clearly. The pace of innovation in the open source community is much higher than in the closed source community. So there's no doubt in my mind that even now, not to say maybe 6 months or a year from now, the best models, period, will be open source models. So that's a given. My talk today is not about this. My talk is about how do we take those amazing models and make them even better so that they completely outperform the closed models on your enterprise use cases. Before I do that, just want to call out why customers prefer small language models. And it's just not me saying it. I've met probably, 200, 300 of them in the last 18 months. And I've consistently heard this. The number one thing they like is obviously accessibility. Because of Hugging Face, or I should say thanks to Hugging Face, and model builders in the open source communities, we have great models to pick from. We can download them in seconds. We don't need to pay anyone anything. We just download them and get to work, right? So that's very cool, and that's a good way to speed up innovation. The models are open source. I prefer to say open weights. What an open source model really is, that's another whole talk, I guess. Not my topic today. But at the very least, you have access to the model architecture, you have access to the model weight, so you know what you're working with, and you can test it and inspect it and find when things work and when they don't work in many ways, right? Which is honestly pretty much impossible with closed models. Privacy and, all right, that's all right, I'll keep it that way. Privacy and intellectual property protection go hand in hand, right? Because when you work with small language models and open source models, you deploy them on your own infrastructure, right? So if you work on AWS, you deploy those models in your VPC. The data that you send to the model and the answers that the model send back stay within your VPC. There's no one else but you looking at that data, and that's the way it should be. Plus, if you train those models on your own data, and we'll talk about that, of course, the models become yours, right? And again, they stay within your VPC. You don't have to go and deploy them somewhere else with the odd chance that something goes wrong and there's a knowledge leak or a security breach. Freedom of choice is very important. With closed models, you can pick from a handful of models. With open source models, you can just pick from almost 1 million models now. There's almost 1 million models on Hugging Face. So you're not locked in, and that means you can find the right model for every single project which is important, and you can, probably upgrade to a better model when a new one becomes available. IT flexibility is also very important. Not everybody wants to deploy or train their models the same way, right? Some folks insist on doing on-prem, maybe because they have to. A lot of folks will use the cloud, et cetera, right? So even then, even in the cloud, you could use EC2, you could use EKS, you could use SageMaker, you could use maybe Bedrock, why not? And again, you have the freedom to pick not only the infrastructure, but also the service, the technology that you want to run your models on. Cost optimization is a central concern these days because we're not living in the sandbox anymore. Projects are moving to production. And, well, ROI and cost performance are everything. So because you control model selection and model size selection and infrastructure selection, you can find the sweet spot for each particular project. Again, something you cannot do with closed models who price per token regardless of the use case. And last but not least, model quality. And again, I've seen enough evidence here to confidently say that a small open source model tailored on quality data will always outperform a generic large model. I used to say almost always. I guess that was 2023. So now I can say always. I've seen it enough, and we, with our colleagues here, do that every single day. So what does a typical workflow look like? So typically you'll start from a pre-trained model. So let's say maybe a Llama 3 model that you grab on Hugging Face. And sometimes it's just good to go, and you don't need to do anything else. It's gonna answer your prompts in a good way, but most of the time, and particularly in an enterprise setting, you need to tailor the model to the domain, okay? And whether that's telco or energy or financial services or retail or manufacturing, and I could go on forever, insurance, etc. Your domain and your company and maybe your business unit has specific domain data and vocabulary and maybe jargon that need to be baked into the model, right? To increase the quality of the generated answers, okay? So you need to go through that workflow. Still, you'll start from a good model, so let's say a Llama 3 model, and you need to go through different steps. And the main 3 steps are, I need to inject new domain knowledge, I need to teach the model how to answer my questions the way I want, and I need to give feedback on what a good answer is and what a not so good answer is, okay? And those 3 steps are continuous pre-training, instruction fine-tuning, and alignment, right? And typically, customers will go through all those steps, bringing data sets for those different purposes, and getting, hopefully at the end of that pipeline, with a model that knows about their domain, knows how to answer questions properly, and is aligned for tone of voice and safety and similar things, okay? So not so easy to do, lots of work, lots of compute, lots of data sets. And I guess what Arcee is doing is trying to simplify this, and I'll show you some examples. So let's zoom in on those building blocks. The first one is continuous pre-training, right? So continuous pre-training means, hey, I want to build, let's say, a telco model, so I'm going to take all the 3 GPP standards in the last 10 years, and I'm going to train my model on that. Or I'm going to take, 1 million pages of Cisco product documentation and train a model on that, whatever. So it's a ton of data, it's billions of tokens. And as you can imagine, it's pretty compute heavy. So option 1, and that's been the only choice for a while, was to do full fine-tuning. So train the full model in original precision, so probably FP16 or BF16 on that corpus of data, right? Problem is, well, we're talking about billions of parameters, billions of tokens, full fine-tuning, and that's compute heavy, that's expensive, and this has stopped a lot of folks from actually doing this. So about a year and a half ago, a new way to train models has been introduced called parameter efficient fine-tuning, techniques like LoRa or QLoRa, which enable large memory savings by only training a fraction of the model, not the full model, right? Introducing maybe even quantization if we use QLoRa. So that's a good step forward. This allows you to train models in a more cost-effective way. Unfortunately, although it works very well for instruction fine-tuning, it doesn't work well for initial training, right? So it's better than nothing, I would say, but the degradation, the price you pay for just training a fraction of the model is pretty high. So recently, Arcee has been contributing to a new technique, which in a nutshell trains, well, first identifies the layers in the model that contribute the most to the prediction, and that's statistical analysis, and then trains only those layers, but in the original precision, right? So this is, in a way, you could say it is still parameter efficient fine-tuning because we're not training the whole model, we're training layers, but we're training them in original precision. So this technique is called Spectrum. You can read all about it, and again, we have the best people here to answer questions on Spectrum. And this is an open source project available on GitHub. So Spectrum will typically train, let's say, the top 25% to the top 50% layers. And depending on where you set that threshold, you get very significant speed up and memory usage reduction without compromising accuracy. So it's almost as good, sometimes even a little bit better than full fine-tuning. And it's almost as efficient and sometimes a little more efficient than QLoRa. So very, very cool technique. Encourage you to take a look at it. So fine-tuning, as I've said, fine-tuning, and I'm sure you've heard of those techniques before, has been, I would say, improved and simplified with LoRa and QLoRa. Right? And those are available in Hugging Face libraries, and I mean, it's household usage almost. So I won't discuss those too much. They're still very good, pretty cost-effective techniques for fine-tuning. One thing people tend to forget is it's not just about the training algorithm, it's obviously about the quality of the data that you train or fine-tune the model on. So people are always obsessed about GPU memory usage, and maybe they neglect the quality of the data a little bit. So we recently released a new project called EvolKit, which is basically a toolkit that lets you improve your Q&A data set. And when I mean improve the diversity, improve the complexity. So by using a high quality LLM, we take your existing Q&A data set and make it better and a little more diverse, a little more complex, and that will automatically improve the quality of your fine-tuning. So another one of our open source projects, right? And we did share a resulting data set on Hugging Face as well. So just in case you haven't seen this, it's been out for a few months now. This is a nice study on taking mostly 7 billion parameter open source LLMs and fine-tuning them on a bunch of tasks, and then comparing the performance to GPT-4. So in a nutshell, what we see is not only that fine-tuning works, right? Fine-tuned models are much, much better models than the base models, so that's good news. But more importantly, we see that all the fine-tuned models outperform the OpenAI models, right? So they outperform GPT-3.5, which isn't so impressive now, but also the huge majority of models also outperforms GPT-4, right? And for some reason, Google Gemma doesn't fine-tune very well, so I wouldn't use it. But if you look at the Mistrals or in Zephyrs, etc., 7B, it's very easy to fine-tune them and outperform GPT-4, okay? keep in mind, those models are 7 billion models. You can run them on very, very little infrastructure, as you will see, right? The smallest GPU instance on AWS today is G5 2XL. It costs $1.2 an hour on demand, and it runs those as a, just like a dream. So from a cost performance, this is way better than anything you can find out there, okay? So let's talk about alignment. So again, RLHF has been out for a while. Hopefully it's not the first time you hear the word. And basically what RLHF is you have human feedback on generated answers from a model, telling the model, well, this answer is, I would rate it, I would score it maybe 7 out of 10. And here's an answer that I think would be 10, right? So given a prompt and a generated answer, some human will give a score and a golden answer, hopefully, right? And once you build enough of those, then you can train the model again using reinforcement learning so that it learns how to improve his own answers based on the feedback that the human gave it, okay? That's the 30-second explanation. And honestly, yes, it did make ChatGPT impressive. Now, there's a dark side to the story, and I'm sure you read about that. RLHF is difficult to scale. We need humans. We need thousands of people, writing answers, scoring prompts, etc. So that's not something your typical company can do themselves. Ethics are completely wrong. Those companies have been using outsourced workers in different countries. And the Kenya story actually made the news again in the last few days. So that's not the way I think we should be building AI. And funny enough, those companies will signal AI virtue every day and every night and every year. And yet they're doing that kind of stuff. So I don't know. Hopefully they sleep at night. And there are other problems like bias and quality. I'm sure you've all seen this. I'm from France, so that kind of stuff resonates. That period of history resonates a little bit. One thing I know, those guys didn't look like that, okay? And the reason why it happened is very interesting, and I won't go into the politics, but I'll just say that if the people providing the feedback all think the same way and all lean the same way, then those things happen. Not saying they happen on purpose, just saying they happen. And of course, complexity and costs are problematic because reinforcement learning is a very heavy technique. It takes a lot of data, it takes a lot of compute. And it's, again, not something that your typical company can do. So a number of improvements have been suggested. I think one of the most popular techniques these days is called DPO. And basically, DPO does away with the human workforce. It does away with the reinforcement learning element. And it can start from an existing data set, like the one you see here. So a prompt, choose an answer. So let's say the golden answer and the rejected answer. And it can just run statistical analysis and automatically learn how to generate answers that are closest to the chosen one and not the rejected one, right? And the cool thing is there are a lot of good DPO data sets on Hugging Face. This is actually one of ours. So chances are, I mean, at least initially in your project, you could very well start with those and align your own model using those preference data sets, possibly without having to build your own. So much faster, much more cost-effective way to align models based on human preference. So we could stop there and say, so yeah, we did improve a few things, right? We can do CPT faster and cheaper with Spectrum. We can have better fine-tuning through LoRa and improve data sets through EvolKit, and we have DPO. But can we just do away with training and fine-tuning completely? Can we get rid of it? I think we can. And that's the point of model merging. And model merging is based on an RC library called MergeKit. So building a great model is difficult. And I guess the first difficulty is defining what great means. Right? It means one thing to me. In my company, it means something different to you in a different company, in a different industry. But going through that pipeline is not simple. So can we simplify that? Right? We have all those training and fine-tuning steps. Again, they need time, they need effort, they need compute, and they slow everybody down. So instead of doing this, because we have 1 million models on Hugging Face, right? Plus maybe the ones we've already built inside the company, can we find models that have the qualities that we need, right? Let's say we want to build a model that can do, code and math and, I don't know, Cisco log analysis all at once, right? Not 3 models, just 1. Well, we can certainly find a good code model out there, right? We can certainly find a good math model out there. And maybe somebody in the company has already built a cool Cisco log analysis model that we need, right? So why would we take those data sets and retrain a single model on all of that stuff, right? Sounds a little bit silly. And that's what merging solves. We literally take the 3 models and merge them, right? In the arithmetic sense of the word, right? So think averaging weights, right? So that's exactly what model merging is. There are different techniques, but at the core, it's really about taking the weight from those models and averaging them out, right? So we're combining task-specific models into a single model without any training, right? So it's not an ensembling technique. Ensembling would be predicting with the 3 and then averaging out. Here, we build 1 model and work with that, okay? The good thing is, because there is no training, we don't need any kind of CPU compute, right? We don't need any kind of GPU compute, I'm sorry. So you can just run this on your laptop on a CPU instance. It's not a very heavy process, right? So no cost for training, no extra cost for inference, no extra inference latency, because at the end of the day, if you're merging 3 Llama 3.8 billion models, you get only 1, and it will have the same size and the same speed as an original Llama 3.8b model, right? So all you have to do is look at MergeKit, select a merging technique, and write a config file. So here's one, and this is using the ties algorithm. I won't go into it. I have a ton of deep dives on my YouTube channel if you want to look at that. But you can pretty much see what we're doing here, right? So we're merging 2 Mistral 7B models who were originally built from this base model. One of them is the Bio-Mistral model. So it's a Mistral model that was trained, pre-trained on biomedical data. And we're merging the vanilla instruction following Mistral, right? Because this one has the domain knowledge we want, the biomedical data, and this one has the instruction following knowledge that we want, right? So we'll just take the two elements and merge them into one. And you run this on a CPU instance in, I don't know, 10, 15 minutes, right? For next to nothing, and you have your merge model, right? So that's what model merging is. So now if we look at our workflow once again, adding merging and some of the other things I discussed, we can modernize and accelerate and reduce the cost of this model adaptation workflow while getting to a much, much better model in the end, right? So merging can happen at every single step. So we can replace training or fine-tuning or alignment with merging, right? And possibly we could only do merging steps. Or we could say, well, maybe have this very specific company data, so I still want to do pre-training, okay? Because it's unique data. I can't find any other model that has already been trained on that. So I'm going to run CPT, and maybe I'm going to run it with Spectrum for efficiency. But then for instruction fine-tuning and alignment, I'm just going to do merging because I'm just going to inherit whatever those llamas or mistrals or whoever or whatever I've already done, right? I don't see any added value in doing that myself, right? And of course, you would do LoRa here and you would do DPO here, and you could use EvolKit to improve your data sets, right? So that's, again, what Arcee brings to the table. Helping you go through that pipeline faster, cheaper, and with higher quality in the end. So how do you do this? Well, a lot of what we do is open source. So you could absolutely, let me go back to this slide. You could run all of this open source. No worries, right? Spectrum, EvolKit, MergeKit, plus the Hugging Face libraries for LoRa, DPO, etc. You could do all of it, okay? For some companies, they don't want to reinvent the wheel. So we have built a cloud platform called Arcee Cloud that does all of that in just a few clicks. So literally everything you saw on that previous slide can be done here in a few clicks. Upload your data, go through the steps. And if we have a Python SDK as well, if you insist on writing code, right? So that's available as a SaaS platform and as a VPC deployment if you want to keep everything super private. But that's not all. So I guess to prove our point, we also build models, okay? So we have a bunch of models on Hugging Face, open source, and you can go check them out. And we're also building commercial models. So this one actually came out like not 2 weeks ago. It's called Supernova. It's a 70 billion parameter model based on the Llama 3 architecture. And this was built using pretty much all the techniques I've described so far. So merging and also model distillation. So starting from the bigger Llama 3.1, 405 billion, and distilling into a smaller model, etc., etc. There's a great blog post. I think, Lucas, you helped write it, right? On the training pipeline. It's got a ton of good details. So it's the best 70 billion model available today, right? To the best of our knowledge. And benchmarks are benchmarks, and we can argue about benchmarks all day and all night. But on this, on the Google IF Evol benchmark, Supernova not only outperforms Llama 3.1 70B, it outperforms Llama 3.1 405B, and it outperforms Claude 3.5 Sonnet and GPT-4o, right? And keep in mind, we don't know what those are because they don't say, but if they truly are, let's say, trillion parameter models, then this is pretty impressive that we can outperform them with a 70B model, right? So let's try this model. So we have a demo. You'll get the slides, I forgot to say. Let's give it a shot. Can you see this? Yes. So it's a demo. You can all try it. It's supernova.arcee.ai. And let's give it a shot. Right? So that's the speed you get. That's the speed you get from a 70B model deployed on quality infrastructure. Right? So faster than the big models, at least as accurate, and the price point, as you would imagine, is much, much lower, right? So I'm not going to prompt this one because in the interest of time, go try it. We get pretty good feedback on it, right? If you want to, so I would test it there, but if you want to also deploy it in your company, it is available on the AWS Marketplace. Let me zoom in a little bit. So if you look for Arcee.ai on AWS Marketplace, you'll see Supernova in there. And you can deploy it to SageMaker in a couple of clicks, right? So that's Supernova. And as you can see, coming back to my initial claim, when I'm saying those models based on open architectures are state-of-the-art and outperform much larger models, we're there. That's it, we did it. And we'll keep doing it. So if you take that model and specialize it on your data, it's going to go even higher, right? So that's the trend. We've built a smaller sibling of Supernova. It's an 8 billion model. So it's called Supernova Lite. It's based on Llama 3.1. And well, we were happy to see just a couple of days ago that it's the best model, the best 8 billion model available today. It's #1 on the Hugging Face leaderboard. Okay, you can go and check that out. So that's pretty nice. Again, you can try this very easily. Just you can deploy it on you can deploy it from Hugging Face if you'd like. And because the model is so small already, 8 billion, you can deploy it on very cost-effective infrastructure, right? So in fact, I can run it locally on my machine. Do I have this running here? Yes. Right? So I have a quantized version running on my Mac. Yeah, I don't know. Let's just use this prompt. Right? Oh, that was a... See? So you can run this 8B model, the best today, best available today, just like that on your local machine. That's where we are, right? So 0 cloud cost. Probably for, I would say, production usage, you would want to run this on AWS, okay? So let me show you two things. First is how we can deploy this on Inferentia 2, which is the AWS accelerator. All those notebooks are on GitHub, so you'll get the link to that, right? So here, all it takes is really say, hey, I want to deploy this on Inf2XL. This one costs, I think, 99 cents an hour. So it's even cheaper than that small GPU instance I was referring to. I'm using the AWS inference container for that, right? And then setting some basic settings and literally calling deploy, right? So wait for a few minutes, and then I have my SageMaker endpoint ready, and I can start prompting it, okay? So why don't we do streaming inference maybe? There we go, right? So that's fast as you need it to be, right? I can't read that fast. And you can run this inside your AWS account for 99 cents, which is, again, the on-demand price, but as an AWS customer, you would optimize that at least 30% very easily, right? And you get full privacy and full control, right? And you can use, as you can see here, maybe that's a little too small, let me zoom in. You can see I'm using the OpenAI prompting format. So if you have OpenAI prompts today, you can just reuse them. Running in your apps, you can just reuse them as is and run them on this model because it supports the OpenAI Messages API, the input and the output, right? So that's a very simple way. But can we get smaller? Of course we can. And I can run this on this machine. So what is this machine? So this machine is a Graviton instance, right? Graviton 4, so that's a CPU instance with ARM cores, so no GPU whatsoever, right? So who thinks we can run this fast on a CPU instance, 8 billion parameter model? Well, let's take a look. So Supernova Lite, quantized to 4 bits on CPU. How many tokens per second do you think? Want to bet? We'll know. Place your bets. 57 tokens per second. right? This instance is an R8 instance, which costs something like, I forgot, $2.5 an hour, right? But when we get the C8G instances, they will be even more cost effective. So state-of-the-art model running at this speed on a CPU instance is where we are today, right? And we can run the 70B model, but I'm still tweaking, so I'm not going to show that today. Right? I guess you'll have to wait for my YouTube video. So summing things up, the one takeaway, honestly, you should all know this by now, but it's worth repeating. There is no model that rules them all, okay? That was the 2023 lie that put a lot of companies in a really, really bad situation, experimenting and sometimes deploying apps connecting to very large closed models that they were told would do everything, only to realize they couldn't, and they cost an arm and a leg, okay? So each project is different. It has different requirements. It has different domain knowledge associated to it. It probably has a different ROI scenario. So you need to study each project separately and find the right model and the right infrastructure for each use case. As we see with our customers every day, small, tailored open source models are the way to go. You take the best open source models available today, which are already extremely close to state-of-the-art performance, and then through clever techniques, you make them even more amazing on your domain knowledge, which is the only thing you care about, right? If you're a doctor and you're summarizing patient notes, you don't need a model that writes cooking recipes or writes poetry, right? If you want to write poetry, that's okay, but if you're a doctor, that's not what you care for. So you just need one thing, but you need it done as well and as cost effective as possible. Training and fine-tuning techniques are moving very fast. All those latest advances, merge kit, spectrum, etc., distill kit, they're hardly a year old. So they're really changing the game in terms of speeding up that adaptation pipeline, reducing the cost, and increasing the quality, right? The three things you care about. So that's what we do. Again, you can probably do all of it open source and reinvent the wheel a little bit, or you can try our platform in the cloud or in your VPC, and of course you can try our open source models. Whoops. So that's pretty much what I wanted to tell you today. A few resources to close. Go check our blog. A lot of good posts in there. Go check out our model and dataset collection on Hugging Face. That GitHub repository is where I put all my AWS notebooks. Okay, so if you're interested in deploying models on SageMaker or through the marketplace, etc., that's where you'll find all the notebooks. And as mentioned before, I have a rather busy YouTube channel where I keep posting AI stuff, AWS stuff, and so on, and you may like that, okay? And this QR code is how to subscribe to our newsletter and stay in touch. And we have a bunch of new launches coming, so I don't think you want to miss out. All right, well, that's really what I wanted to tell you. So thanks so much for listening. Again, my colleagues are here for questions, and I guess I can take a few too. Thank you very much.